Hang on to it, Marco, because I'm going to need you to freeze it when we're all done. So just leave it close by. Thank you, sir. Okay, so today we're talking about the domain and range of linear applications. I want someone to tell me what the I can statement is for that. It should be in your journal. What is the I can statement? It should be in your journal. I mean, I know what the I can statement is, but I want you to use your journal appropriately. That's from yesterday's I can. Yeah, I can identify. So let's start with that. Whoops, not in highlighter color. I can identify the domain and range Oh, thank you. I can identify an appropriate. You're amazing. An appropriate domain and range. Was for a linear function, right? For a linear function. And say the rest again, please, and thank you. Oh. Okay, so I can identify an appropriate domain and range for a linear function in context. That means, what does it mean actually? Like, what is the real world application? In context. And predict values based on a linear scenario. Okay, so I can identify an appropriate domain and range for a linear function in context and predict values based on a linear scenario. So I asked this question last period, and I think I had 3 kids who were able to answer this. So what does it mean when I ask you about the domain? What is that? Both of you are right. All of you, say it again. X values, input values. Yeah. So the domain, that stands for the X values. They're the inputs. So if the domain is the X values or the inputs, what is the range? Good job. The range is the Y values or the outputs. Good job. If you're looking at a graph, so I'm just going to sketch a graph right over here off to the side. This is my x-axis, and this is my y-axis. What axis do I look at for the domain? So for the domain, I look at the numbers across the x-axis. That's horizontal. And if I'm looking for the range, I look for numbers on the y-axis. That's my vertical. Okay. That's important to remember because not always is it given in a table. Sometimes we have to determine those from a graph, right? So that's helpful. Alrighty. A warehouse is keeping track of its inventory of cardboard boxes. Braden, will you pick your head up, please, and thank you. At the beginning of the month, they had a supply of 1,275 boxes. They use boxes at a rate of 75 per day. This can be modeled by a linear function. How many do I begin with, Chris? You learn better with your eyes open. Yes. How many do I begin with? I believe yeah. This is the beginning amount. This is the beginning. It says it right here. You begin with this much. What variable represents the beginning? Aiden, can you move your hair out of your, or Andrew, can you push your hair out of the way so I can see your face? Thank you. What variable represents the beginning? B. That means B, God bless you, equals 1275. B is the beginning. It says it, they use boxes at a rate. That word rate stands for, whoops, that was awful, slope. That word rate stands for slope. So what is the slope? Okay, so M equals 75. Are we adding 75 boxes per day? Are we adding 75 boxes to the pile each day, or are we taking them away? We're taking them away. So that means that my slope is going to be negative. Good job. Has to be a negative slope because we're using these. We're taking it away. So what is the equation going to be? Yeah. Good job. Y equals negative 75x plus 1,275. Okay. So question A says, consider the domain of the function. So I've given you a domain below. Tamara, will you close your computer for me so I know I got your attention? Thank you. So consider the domain of the function below. So I'm saying, hey, these are the input values. These are the input values. Which one of these values doesn't belong? Which one of these values doesn't belong? Well, I want to talk about what the inputs and the outputs are. So what am I inputting each day? What value does this represent? My input is the what? That's my slope. What am I using 75 of? I'm using 75 what? How often? So my input is the number of days. And if my input is the number of days, my output is the number of boxes that I have left. Okay. So do any of those numbers look weird to you as an input for the number of days? Aurora. 3.2, yeah. This is not a whole number. We need number of whole days because we're using it per day. So we can't do a fraction of a day. Okay. Does anything else look weird? Say that again. Yeah, the negative. Does anyone in here have a time machine? No. So you can't go back in time, neither can I, right? So you cannot have negative time. It's not possible. Can't have negative time. Okay. So I want you to write that down. So those are the two that are wrong. Those are the two that don't belong, and that's why. You can't have negative time. That doesn't make any sense. Okay. So question B says, is 325 an appropriate range value? That means, is 325 a possible number of boxes left? That's what that's asking. So how am I going to figure that out? So number of boxes I have left is represented by what variable? Y. So that means I'm going to let Y equal 325. I want you to take your face off your hand. Put your arm down. That's what I want. Okay. So here we go. I'm replacing the y in this equation with 325. So that's a 7. Replacing the y in this equation with 325. So 325 equals negative 75x plus 1,275. I have to figure out if it's got a good input, right? I need to figure out what x is. How am I going to do that? Yeah, I'm going to subtract 1,275 from both sides. Minus 1,275. Okay, so let's see. I think that's negative 950 equals negative 75x. What would I do next? Yeah, divide both sides by negative 75. Divide both sides by negative 75. What does x equal? Didn't you get 12.6 repeating? Yeah. Can we have an input value that's not a whole number? No. So is this an appropriate range value? The answer is no, because its input is not a positive integer. We're talking about integers, we're talking about whole numbers, right? Whole numbers, positive and negative. But we can't have negative ones, so we just want positive integers. So no, this is not possible. That range value is not possible. There's no input value that you could have that would give you that. How could I check this with a calculator? How could I check this with my calculator? I'm going to write down some calculator options or operations. I want everyone to go to y equals. Push the y equals button. So we're going to input that equation. Pick up your calculator. It's not a suggestion. It's a requirement. Pick up your calculator. And y equals, and I want you to put negative 75x plus 1,275. And we need to look at the table of values. How do I get to that? Second graph. So you're going to press the second and the graph button. You're going to look at your table of values, and you're looking to see if you have an output of 325. Do you see that anywhere in your table? You do? No, you don't. That's because your table is made with integers, like 1, 2, 3, so on. So this is not possible. Do you see how you didn't have to really do any math? You could have just put the equation into your calculator. Okay. How many days until the warehouse runs out of boxes? So if I run out of boxes, how many boxes do I have? 0. So this means the number of boxes equals 0. And the number of boxes is represented by the variable y. Okay. So do we have our calculator still pulled up? Well, yeah. So our calculator, you're looking for x and a y value. You're looking for a y value of 0. 17. You run out of boxes after 17 days. So after 17 days, you have 0 boxes. So So once you can come up with an equation, you can let your calculator really do all of the input outputs for you, right? You can let your calculator do all of that thinking for you, especially when your input values are integers, because that's typically how your table is set up in integers. I mean, we can change it, but we're not there yet. Okay? Who has questions about that? Raise your hand if you need more time. All right, let's go to question number 2. A baby cow, known as a calf, is born with a weight of 62 pounds, and the calf gains 2.5 pounds per day. So, what is the beginning, like when the calf was first born, when its life begins, how much does it weigh? So what does this 62 pounds represent? Yeah, this is B. B equals 62. It's the beginning. The calf gains 2.5 pounds per day. This is the rate that it gains weight. This word per. So when you see the word rate or per, that means slope. That's important. When you see the word rate or the word per, that means slope. So what is my slope? And is the cow getting bigger or is it getting smaller? Is it gaining the weight or is it losing the weight? It's gaining, so that means my slope is positive. Okay, so we need to write an equation using y equals mx plus b. So y equals, say it again, Loriana. Yeah, y equals 2.5x plus 62. But now we want to do a variable change. We want the weight of the calf, the total weight, to be W. And we want the number of days. It gains 2.5 pounds per day. So that's my X. X is number of days. So 2.5 D plus 62. And when it says write it as a function, we typically do it like this. W of D, just like F of X. So the weight depends on the number of days. The weight, depending on the number of days, is 2.5D plus 62. So we write it using slope-intercept form, and then we change out our variables, okay? Questions? Okay. What is the weight of the calf after 2 weeks? So what is this asking? It's asking what is W. So I'm asking you, what are we going to input? Say that again. Yeah, we're going to input 14. It took us a little bit to figure that out last period. So 2 weeks equals 14 days. And D stands for the number of days. So we're going to use an input value of 14. So I'm going to take this equation, W of D equals 2.5D plus 62. And I'm going to replace the D with the number 14. So W of 14, that means the weight after 14 days is the same thing as 2.5 times 14 plus 62. So what is my weight after 14 days? Do the whole thing. The weight after 14 days is 97 pounds. So the calf weighs 97 pounds after 14 days. The calf weighs 97 pounds after 14 days. Describe an appropriate range. So remember, the range is the output values. So what would be an appropriate range? We don't have to list it using numbers. We just have to describe it. So what do you guys think? Andrew, what is the smallest output value we're going to have? What's the smallest that calf is going to weigh? Yeah, the smallest weight. The smallest weight is 62 pounds. That means that our range, our Y values, are going to be greater than that. So how do I show that everything greater than or equal to 62? How do I show that? We're talking about our weight, our output. Yeah. We want to write it in set notation. So remember, we use this little, we say squiggly bracket, the weight such that W is greater than or equal to 62. And I'm going to label this as my range. This is a good description. I mean, we're able to write inequality for it. We can write it as an inequality. We know that 62 is the smallest it's ever going to be, right? According to this information. So the range is going to be any number that's greater than or equal to that. How old is the calf when it weighs 127 pounds? Chris A., what is this actually asking me? So what am I trying to find? I'm trying to find the age in terms of how many weeks, days, months, years, what? How are we measuring its age? When we look at our equation, W of D equals 2.5 D plus 62. What does D stand for? Days. So we really want to know how many days. How many days old? That's what we're looking for. This weighs 127 pounds. This is my output. So what am I going to do with that? This is my output. Where does the output go in the equation? Where does the output go? Is the output D or is the output W of D? Yeah, the output is the weight. The output is right here. This is my output. So 127 equals 2.5 D plus 62. How are we going to solve that? What should we do first, Marco? How would we solve that equation? How would we get D all by itself? What should we do first? Say again. Do you see this equation right here? If you were trying to get D all by itself, what would you do first? We don't turn it into a negative. We add the opposite. So the opposite of 62 is a -2. We're not changing the sign of the 62. We're adding a -62 to both sides or subtracting it. Okay. So 127 minus 62 is 65 equals 2.5 D. Now what are we going to do? Divide both sides by 2.5. Divide both sides by 2.5. And we find out that D equals, D equals 26. So how old is the calf? So the calf is, okay, I want you to go back there by Jamari and stand up. The calf is 26 days old when its weight is 127 pounds. The calf is 26 days old when its weight is 127 pounds. Do you think that we could have done that with our calculator? What do you think, Peter? Could we have figured this out with our calculator using the y equals? Yeah, I think we could have. I'm going to write this off to the side. We could have gone to our calculator. We could have gone to the y equals button, and we could have put in the 2.5x plus 62. Then press the second graph. And what would we be looking for? If we did this in our calculator, what are we looking for? Yeah, we're looking for y equals 127. And that happens when x is 26. Yeah. So we didn't have to solve it that way. We can let our calculator table of values do that for us. I want you guys to know how to do that. I want you to be able to do both, right? Sometimes you get to use a calculator. Not always, but sometimes. So we have to feel comfortable with that. We have one more question. Raise your hand if you need more time. No? Okay. Number 3. Jessica is ordering shirts online that cost $12.50 each. That means she's paying $12.50 per shirt. Well, I told you earlier that the word per is a slope word, but per and each mean the same thing. So each is also a slope word. That's a slope word. So what is the slope? M equals what? Bella, M equals what? What is the word each referring to? Yeah, the cost per shirt, $12.50. So that's my slope. The shipping, the initial cost, no matter how many shirts she orders, this is the initial fee. She's got to pay it regardless of how many shirts she orders, is going to be $16. That is my y-intercept. So which equation here shows that it has a slope of 1250, Elisha, and a y-intercept of 16? Equation 1, 2, 3, or 4? Good job. Equation number 3. So equation number 3 is the is the equation that we're going to use. Equation number 3 is the equation that we're going to use. So before we explain why the range is appropriate or not, I want us to go to our calculator. Calculator. And where are we going to go on our calculator? Y equals button. When you go to the y equals button, I want you to push in the number 12.5x plus 16. And then where are we going to go? Second graph. I want you to look at your table. Is it possible for us to order negative shirts? No. Okay. So I'm going to start my table with 0. And I want you to look at all of your outputs. What is the smallest number that you have there for an output? When you look at your table, what's the smallest output? Oh my gosh, the smallest output is 16. What's the largest output? What's the largest output, Braden? What's the largest output, Jamari? Peter, what's the largest output? Riley, what do you think? Say again. There is no specific largest value, right? Because you can order as many shirts as you want. So how do we say that it goes on forever? How do we say that? Infinity. So the largest number is going to be positive infinity. So does this represent that the amount that you spend, A, is anything that is greater than or equal to 16? Yes. Yes. Okay. Using the equation from above, how many shirts did Jessica order if the total amount spent is $222.25? So that means that we have to let A, the total amount that she spends, equal $222.25. The equation, A equals 12.5 S for the number of shirts plus 16. So we're going to take this value right here, and we're going to substitute it in for A. We're going to plop it right there. We're going to substitute it in. So let's see. 222.25 equals 12.5 S plus 16. How am I going to figure out how many shirts I ordered? What should I do first? Subtract 16 from both sides. So 206.25 equals 12.5 S. Ariana, what would you do next if you were trying to get S all by itself? That says 12.5 times S. What's the undo if multiply? Yeah, we're going to divide. We're going to divide both sides by 12.5. We're going to divide both sides by 12.5. So when we do that, how many shirts did she order? Jamari, how do you go to a website and order 16.5 shirts? You can't. You can't order 16.5 shirts. So is this an appropriate domain value? No. Why? That's exactly right. Because you cannot order half of a shirt. What does your domain values have to be? What are your domain values comprised of? What would be appropriate domains? Whole numbers. Oh my gosh, I love that. Say again. Yeah. How about positive integers? Your domain has to be positive integers. It can't be a half or a third of a shirt or a negative shirt. That's not even possible, right? Okay. Questions about this? Did we answer all of our questions? Okay. Marco, will you hit the freeze button for me? Thank you, sir. You're awesome.